Hey everyone, ready to explore the universe? Today we're diving deep into time travel and those incredible telescopes that can see billions of years into the past.
Should be fun.
We've got two cool YouTube videos to guide us. One about Elon Musk and this crazy thought experiment about twins and rockets, and another one on that awesome James Webb Space Telescope.
It's always fascinating to see how we grapple with the concept of time.
Right, like it's such a fundamental part of our existence, but it's still so mysterious.
Absolutely.
So that first video, the Astrocoby one, talks about Elon Musk and this idea of time dilation. That always messes with my head.
Yeah, time dilation. It definitely challenges how we normally think about time.
Oh, sure.
The video explains it using this story about twins, right?
Oh.
One twin blasts off into space on a rocket going super fast, almost the speed of light.
Okay.
And the other twin, they just stay here on Earth.
Living their best life.
Haha, exactly. But get this, when the space twin comes back, they've aged less than the twin who stayed on Earth.
Whoa, wait, so it's not just about the distance they traveled, it's like time itself is different for them because of how fast they were going.
You got it. Time dilation, which comes from Einstein's theory of relativity, basically says time is relative.
Yeah.
It's not a constant thing that's the same everywhere for everyone. The faster you move, the slower time goes for you compared to someone standing still.
It's like in that movie Interstellar.
Yes, exactly like that.
Fizzle crazy.
Yeah, it's mind-blowing stuff. The twin on the rocket in the video, they could come back years younger than their sibling. It's like something straight out of science fiction.
I know. But you're saying this time dilation thing, it's not just a made-up idea.
Nope, it's a real thing. We see it happening with particles in those giant particle accelerators, and even in our everyday tech, believe it or not.
Really?
Yeah, like GPS satellites, those have to adjust for time dilation to work right.
Wow, never thought about that. So
Forward.
time dilation is built into our phones. That's wild.
It is. Of course, the video uses a pretty extreme example to make the point, right? We can't travel at the speed of light, not yet at least.
Right.
But what we should take away from this is that time isn't as fixed and absolute as we usually think it is.
Okay, so we can't travel at those crazy speeds, but is there any way to actually see these time dilation effects in action? Or I guess even more broadly, can we see things that happened in the past? Aside from, old photos and stuff.
Well, that's where the James Webb Space Telescope comes in. That thing is like a window to the distant past.
That brings us to the Drove-Rethi video.
Oh.
It talks about how the JWST can actually see back in time, but how does that even work?
Light, my friend. It all comes down to light. Light travels super fast, the fastest thing in the universe, but it still takes time to get places.
Okay.
So when you look at something really far away in space, like a distant star, the light you see from it has been traveling for a very long time, sometimes billions of years.
So like when I look at a star, am I seeing it as it was years ago?
You got it. Think about the sun. It takes about 8 minutes for the light from the sun to reach us. So when we look at the sun, we're actually seeing it as it was 8 minutes ago.
Wow, that's trippy. But the James Webb, it can see way further back than that.
Oh yeah, much further. The JWST can see back about 13 billion years, almost all the way back to the beginning of the universe.
No way. To put that into perspective, how far back could Hubble see?
Hubble, which is already a huge step forward, could only see about 12.8 billion years back.
So we're getting close to seeing the Big Bang itself. That happened, what, like 13.8 billion years ago?
Exactly. It's incredible. But how can the JWST see that far back? What's so special about it?
Well, one key is that it's designed to see infrared light.
Infrared, so like heat vision.
Kind of. You see, the light from those super distant objects, it's been traveling for billions of years, right?
Right.
And during that time, the universe has been expanding, stretching those light waves out. It's called redshift.
Redshift, so the light gets kind of redder. Exactly. It shifts towards the red end of the spectrum. And that's why infrared is so important. The JWST can capture this faint red-shifted light coming from the early universe, light that we can't see with our own eyes. It's like having special eyes that let us see back to a time when the universe was just a baby.
That's mind-blowing. So not only can the JWST see incredibly far away, but it can also see through stuff that would normally block our view, right?
You're exactly right. The Drove-Rethi video mentioned that too. Infrared light can actually penetrate clouds of gas and dust that would block visible light. And that's super important because those early galaxies were surrounded by huge dust clouds.
Ah, so it's like the JWST has X-ray vision.
Kind of. It can see right through those obstacles and peer back billions of years.
So cool.
It is. And it's not just about stars and galaxies either. The JWST can study the atmospheres of planets orbiting other stars, even search for signs of life out there.
Whoa, that's amazing. It's like we're on the verge of discovering alien worlds.
The possibilities are really endless. Who knows what other secrets the JWST will help us uncover as it keeps exploring the universe? We are truly living in a golden age of space exploration, and the JWST is at the forefront of it all.
Okay, so we've got time dilation where time can speed up or slow down depending on how fast you're moving, and we've got these powerful telescopes that can see billions of years into the past. It's a lot to process, but it's super fascinating.
It is. And the really cool thing is these two seemingly separate ideas, they're actually connected. They both let us explore different sides of time just in different ways. Time dilation is about how individuals experience time, while telescopes give us a glimpse into the vast history of the universe.
It's like we have two different ways of looking at time. One zoomed in on a personal level, and one that shows the big picture. But before we dig deeper into that connection, let's take a quick break. We'll be right back to continue our exploration of time travel and telescopes. And we're back. We were just talking about how the James Webb Space Telescope can see billions of years into the past. But what makes it so good at capturing that ancient light? The Dhruv Rathi video mentioned it's not just about having a bigger mirror.
You're right, it's much more than that. It's a real engineering marvel, that JWST, designed to operate in the harshness of space, picking up those super faint signals from the distant universe. And one of the biggest challenges they faced was keeping the telescope incredibly cold.
Cold? Why does it need to be cold? Isn't space already, like, freezing?
Oh, space is cold, no doubt. But the JWST, it's designed to see infrared light, which is basically heat radiation. If the telescope itself is giving off heat, it would mess with the faint infrared signals it's trying to pick up, like trying to hear someone whisper at a rock concert.
Ah, makes sense. So how do they keep it cold? It's not like they have a giant refrigerator floating out there.
Right, that's where the sun shield comes in, this massive, massive structure about the size of a tennis court. Think of it like a giant parasol shielding the telescope from the heat and light of the sun.
I remember seeing pictures of it during the launch. Pretty impressive.
It is. It's made up of 5 layers of this special material, Captain. Each layer is thinner than a human hair.
Wow, seriously.
Yep. And they're separated by vacuum gaps to make them even better insulators.
So it's like a super high-tech space blanket, keeping the telescope nice and cool so you can see those faint signals.
Precisely. It keeps the telescope at a chilly negative 223 degrees Celsius. Much colder than the coldest temperature ever recorded on Earth, naturally anyway. And that extreme cold, it's absolutely vital for the JWST's instruments to work properly.
That's amazing. It's all designed so intricately. Really makes you appreciate the ingenuity of the people who built this thing.
Absolutely, and we haven't even talked about its location. The JWST isn't orbiting Earth like Hubble did. It's positioned about 1.5 million kilometers away at a special spot called the L2 Lagrange point.
Why there? What's so special about that spot?
Well, the L2 Lagrange point is gravitationally stable. The telescope can basically park there and stay in a fixed position relative to both the Earth and the Sun. It's ideal for a few reasons. First, it keeps the telescope out of Earth's shadow, so there's a constant supply of sunlight to power its solar panels.
Okay, so it's got constant power. What else?
Second, being at the L2 point means that the sun shield can effectively block sunlight from both the sun and the Earth. So the telescope is always in those cool, dark conditions it needs to operate.
So it's like a perfect cosmic parking spot with an amazing view of the universe.
Exactly. And because it's so far away, there's less interference from Earth. The JWST's location, along with its advanced tech, makes it the most powerful space telescope we've ever built. It can see deeper into the universe and further back in time than we ever thought possible.
It's incredible. But the video also mentioned something about single points of failure during its development. What do they mean by that? Sounds a little scary.
It is a bit, when you think about it. Because the JWST is so complex and was such a huge project, there were hundreds of points where a single failure could have ruined the whole mission, like deploying that sun shield. If any one of those 5 layers hadn't unfurled correctly, the whole thing wouldn't work.
That must have been incredibly stressful for everyone involved.
Oh, absolutely. There were over 300 of these single points of failure identified during development. The fact that the launch and deployment went off without a hitch, it's a true testament to the skill and dedication of the people who worked on it.
It's amazing the level of precision and coordination involved in pulling that off. Shows what we can achieve when we set our minds to it.
Couldn't agree more. And it wasn't just a NASA project. The European Space Agency and the Canadian Space Agency were involved too. A real global effort. A testament to international cooperation and the pursuit of knowledge.
And speaking of knowledge, the JWST isn't just about looking back in time, it's also being used to study things happening right now, like the search for exoplanets.
You got it. Searching for exoplanets, those planets orbiting other stars, that's a major part of the JWST's mission. And because it can analyze the light passing through their atmospheres, we can learn about their composition, their temperature, and maybe even detect signs of life.
Wow, so we could actually find alien life with this thing.
The possibilities are incredible. Who knows what other secrets the JWST will reveal as it keeps peering into the universe.
It's mind-blowing to think about, all those discoveries waiting to be made.
It is. But before we get too lost in the future, let's take a step back and think about what we've learned so far. We've talked about the crazy concept of time dilation, learned how telescopes are like time machines, and we've seen the incredible technology that makes the JWST such a powerful tool. But there's one more piece to this puzzle, one more connection we need to explore.
Right. We've been talking about time dilation and telescopes like they're separate things, but there's something deeper there, something that ties them together.
Exactly.
And I think that's what we'll unravel in the final part of our deep dive. Welcome back for the final part of our deep dive. It's been quite a journey exploring time travel and telescopes. From twins aging differently to seeing billions of years into the past, it's all pretty mind-blowing stuff.
It really is amazing how these ideas challenge our everyday understanding of the universe.
They really do.
Yeah.
But like we were saying before the break, there's a connection between time dilation and these powerful telescopes, a link that ties them together.
That's right. We've been talking about them separately, but they're connected in a really interesting way.
I'm all ears. What's this link between a twin aging slower on a rocket and a telescope looking back to the early universe?
The link is light. Both time dilation and telescopes, they rely on the properties of light to work their magic. Remember, with time dilation, it's the speed of light that creates the ultimate speed limit, influencing how time is experienced.
And with telescopes, we're capturing light that's been traveling for billions of years. It's like we're looking back in time, seeing things as they were long ago.
Exactly. Those photons, those little particles of light, they're like time travelers themselves. They carry information about the universe as it was billions of years ago.
So by studying that ancient light, we can piece together the history of the universe, understand how stars and galaxies formed and changed over time.
Right. It's like having a cosmic history book written in light.
So time dilation and telescopes, they both give us a glimpse into different timescales. Time dilation affects how individuals experience time, and telescopes offer us a window into the entire history of the universe.
That's a great way to put it. Two different lenses to view time. One focused on the individual experience, the other showing the grand cosmic picture. And by studying both, we get a deeper appreciation for how the universe works and how space and time are connected.
It's also fascinating, but it also raises some big questions, like, if we can see billions of years into the past, does that mean the future is already set in stone? What about free will?
Those are questions that have puzzled people for ages. Our understanding of time has come a long way, but we still have so much to learn. The idea of free will, especially when you throw relativity into the mix, it gets pretty complicated.
No kidding. But it makes me wonder, if we can keep building even more powerful telescopes, could we theoretically see all the way back to the Big Bang? See the very beginning of time?
That's the dream for many cosmologists, to witness the moment of creation. But observing the Big Bang directly might be impossible. The early universe, it was so dense and hot that light couldn't even travel freely.
So it's like trying to see through a wall of fog.
Exactly. There's a limit to how far back we can see, even with incredible telescopes.
But the JWST is getting us closer than ever before, right?
Absolutely. We're seeing it further back in time, capturing light from the very first stars and galaxies, those early chapters in the universe's story.
It's amazing to think about how much we've learned about the universe. Yet there's still so much more to discover.
Every new discovery brings new questions and pushes the boundaries of our knowledge. That's the beauty of science. It's a never-ending exploration.
Well, I think that brings us to the end of our deep dive into time travel and telescopes. It's been an incredible journey. We've explored how time can be stretched and compressed, learned how light lets us peer into the past, and seen how the James Webb Space Telescope is revolutionizing our view of the cosmos.
It has been quite a journey. We've touched on some really profound questions about the nature of time, the beginning of the universe, and the vastness of space.
Questions that will continue to inspire scientists and dreamers for generations to come. Who knows what incredible discoveries await us in the future? Maybe one day we'll even crack the mystery of time itself.
Maybe so.
But for now, we'll keep looking up at the night sky, filled with curiosity and wonder, knowing that there's an entire universe out there waiting to be explored. Thanks for joining us on this deep dive. We hope you enjoyed it as much as we did.
Keep exploring, keep asking those big questions, and never stop looking up.